This is Shushmita, and today is session 8 of units and measurement. If you remember, I had given you some problem in the earlier session for error calculation, rounding of figures, and vernier scale and screw gauge. So today we are going to talk about those. Let us start with the first problem. Here they have given us the diameter of a capillary tube and the height of the rise of water in the capillary tube, and they want us to find out the error in the surface tension due to the rise in the capillary. Now here they have not given the error in the measurement of diameter and height, but they have given it indirectly in terms of decimal places, because if my data is of the order of 1.25, then the error can come in the last decimal digit. That means the error is of the order of 0.01. In both the data, they have given us up to 2 decimal places, so our error will come in the last decimal place, or in both the cases the error will be 0.01. So here they have given us the diameter is 1.25 10 to the minus 2 meter. So the error comes out, or delta D is 0.01. Similarly, in case of delta H, it is 0.01 up to 2 decimal places. So they have also given us the expression for T. Now radius is nothing but half the diameter, so we can write in terms of diameter like this. And in error, G have no role because G is a constant. So the percentage error in T is the percentage error in the calculation of D and the percentage error in the calculation of E. I am ignoring the factor 10 to the minus 2, and for the height also I am ignoring the factor 10 to the minus 2, because when we will take this ratio, the 10 to the minus 2 and 10 to the minus 2 will cancel out. So in the simplest form, we can write the error in delta D, which is 0.01, and the value of D is 1.25, plus the error is the same in the measurement of each, and the value of H is given to be 1.45. So this will be the percentage error if we multiply this quantity by 100. So let us calculate it by using a calculator. 0.01 by 1.25 plus 0.01 by 1.45. So 0.01489. We have to multiply this with 100 to get the percentage error. So this becomes 1.48%. So if we approximate this, because this digit is non-reliable digit, the last digit, because the error occurs in the last digit, and we had learned the rules for the rounding off. If you remember, the last digit is 8, which is greater than 5, so we will have to add 1 to 4, that becomes 5. So our answer is 1.5%. Moving on. They have given the expression for heat generated in a circuit because of current flow, and they have also given us the error in percentage measurement of the current, the resistance, and the time. They want us to find out the maximum error in measurement of it. So it is very simple. The expression of Q is I square RT. This is also called the Joule heat loss. So the relative error in Q is, we know if I is to the power 2, then we will have to multiply the error in I by 2. Into this. So 2 into the percentage error in measurement of I is given as 2%. That in the measurement of R is given as 1, and also in the measurement of T is 1. So 4 plus 2, which is 6%. The error in measurement of the heat will be 6% in this case. Now let us look at the third problem of today's class. So they are using a vernier scale to measure the length of a cylinder, and they have given us the smallest division on the main scale is 0.5 millimeter. That means 0.5 is our 1 main scale division. They have also given that 9 main scale division equal to 10 vernier scale division. What does that information provide you? It gives you the least count of our vernier scale. So the least count is 1/10 main scale division, or in millimeter 1/10 into 0.5. Now what is the reading in our scale? It is 78 division of the main scale and 6 division of the vernier scale. That means 78 division on the main scale plus 6 division on the vernier scale. 78 into 0.5 plus 6 by 10 into 0.5. So 78.6 into 0.5, that is 0.3439, and here will be the decimal. So this much millimeter, but the answer they are asking in centimeter. So this is the correct answer. We will now move on to the next problem, and here they have given us a screw gauge, and they are also telling us that the pitch is 1 millimeter. And there are 100 divisions on the circular scale. What does that mean? That means our least count is pitch divided by total number of divisions on the circular scale, or 1/100 millimeter. When nothing is put in between the jaws, the zero of the circular scale lies 4 division below the reference line. So here they are giving us some information about the error present in the equipment. Ideally the zero should lie here, but the zero lies 4 division below. What does that mean? That means if our object is like this, but we are measuring with the scale for which 0 lies ahead of the starting of the object, so the measurement that we are getting, our measured value, is greater than the true value or the true size of the object. So we have to subtract the error from the system, or the error is itself a positive error. How much positive error is that? That is 4 divisions on the vernier scale, or 4/100 millimeter. Now they have put the steel wire in between the jaws. So now we are taking the measurement of our object, and it is 2 main scale division. So our reading is 2 main scale division, that is 2 millimeter, and 67 divisions on the circular scale. So circular scale reading is 67 multiplied by the least count. This is our reading. So 2 plus 67 by 100, which is 2.67 millimeter. That is our reading. But we also have an error, and we will have to subtract that error from our system. So it becomes 2.63 millimeter. And that is our answer. Moving on to the last problem of today's class. They have given us a screw gauge for which the main scale is in millimeter. So each of the main scale division is equal to 1 millimeter. The cap of the instrument is divided into 100 equal parts, which means that the circular scale has 100 division. Find the diameter of a wire if number of division on main scale is completed. Cap has been moved through 37 division. So that means no division on the main scale. So it falls somewhere between 0 and 1. And the circular scale shows 37 divisions, or the 37th on the circular scale coincides with the line of the linear scale. So it is 37 into least count, that is our reading. They have given us information about zero error, which is -3 divisions. So our zero error is negative, and the zero error is given by minus 3 into the least count. Now to find out the least count, we also have to know the pitch. The pitch is not given here, so for the moment let us consider the pitch to be 1 millimeter for the sake of solving the problem. So if the pitch is given to be 1 millimeter, then we can write that the least count is 1 by, there are 100 equal parts, so there are total 100 divisions on the circular scale, and our least count comes out to be this. So our reading is 37 into least count, or 0.37 millimeter, and our error is minus 3 by 100, which is minus 0.03. So this error will be added up to give our final reading as 0.40 millimeter. Hope you understand it clearly. That is all for today. If you have any doubt regarding unit and measurement, vernier scale, screw gauge, or error correction or rounding off, you can ask in the comment section below. In our next session, we will be starting kinematics. So see you in the next session. Till then, take care. Bye bye.